notations. Okay, and the grammar given below, string can represent a set of lowercase words. Let's use all of expression to denote the set of words the expression represents. Okay, grammar can be understood by simple examples. Single letters represent a singleton containing that word. Okay, I mean, I guess that's okay. When we take the common delimited set of two or more expressions, we take the union of the possibilities. So, okay, that seems reasonable-ish for now. Usually I read all these questions, but this is a little bit wordy, so I'm just gonna. I mean, there's a link. I'll link it again later on request, but they should have the number up top, so I don't, I guess they don't make it for streaming. Anyway, when we concatenate two expressions, we take the set of possible concatenations between the two words, where the first word comes from the first expression and the second word comes from the second expression. Excuse me. Oh man, whatever I had for lunch did not feel good. Wait a second. Okay, so kind of like a course product, essentially, right? Or was it a Cartesian product, rather, is what we're doing here. So that's when you concatenate two things. Formulate the three rows of our grammar. Okay. Yeah, okay. Given this, return the sorted list of words that the expression represents. Huh. Man. Okay, I mean, this in theory doesn't seem too tricky. I'm just trying to think about it. I mean, in concept, nothing is tricky. I think I understand the question is what I meant. I understand the problem. But now I'm trying to think what are within the bounds, right? And you only have one, and these could kind of go recursive. Okay. This is just a set of that. Man, you're gonna make me type, John. But are there multiple concatenations? When we concatenate two expressions. Okay, but how does this combine with the GH? So this should have 4. So this, I guess this is just 2 to the 8, to the 3, which is 8. Right. Okay. I mean, I think think of just doing it naively, but I also would I think there's no. I mean, yeah. Yeah. I mean, I wouldn't say it depends on what you mean by naive, but I think just like parsing and recursively and generating may be the way to go. I think the thing. Oh, this is a really weird expression, actually. But also just trying to think. Yeah, so I'm just trying to think what is the. Okay, let me step back for a second. But so the first thing I think of is maybe just doing it naively, in some sense of the word, which is just to like the parser expression and then just do it recursively. I think the only reason why I kind of say that that's good is because, or possibly good anyway, is because, well, you have to output not just the number of number of expressions or number of words rather. Sorry, number of words, but you have to actually output the words. So in general, if the result is too big, then you have to, like, there's no easy way to get around it. Like you have to return the entire set anyway. And after that, I think it's just recursion. But yeah, okay. What language should I like for this? Man, I'm thinking of doing C# or Java and just use regular expressions. But maybe that actually gets me in trouble, so maybe not. Yeah. No, we could just probably do it. Yeah, I mean, I think there's no easy way to do it. It's just I just have to do it. I'm just trying to think about what's the quickest way, and I think there aren't any ambiguity with expressions. I think like you could just use any old language, maybe. And just parse the expression. Think about this. I think one thing that let me think about what are the other cases that I can look at. Like, for example, can you do so you do something like recursively, like yeah, so something like that effectively means oh, whoops, that's why the coloring is a little weird. All right, is that right? So you definitely have to do some kind of like recursive expressions, but that's fine. Yeah, I mean, there's really no way around it. And then you have some messy E thing like this, but okay. Damn it, John, I hate you. I just want to do something quick, but also the Zoom a nightmare to test, but okay. What is the first thing that I want to do? By given an expression. I just do recursive descent. Yeah, okay. I mean, I think I spend enough time not doing anything. This is a pretty straightforward one in theory. What is set in C#? Hash set. Maybe not. Is that generics? Yeah. Also set is probably not probably a keyword. I want to do it here. No. Yeah, I know this isn't quite right, but where does that go? To away. Yeah, I mean, we'll fix the interface later. The reason why I have it separately is because I might do some other stuff here, but I could be wrong. Can I do better? The first character is just chop it off recursively then. This interface might also have to change, but that's fine. Mm. So now you have to merge. I think the thing that's a little always just a little annoying is that there's no explicit operator. I guess essentially, actually, maybe that's what I should do. Should have done to begin with. All right, let me recalculate it. Yeah, okay. Maybe I should pre-process it in the first place. Because I think that was the part that I was always having a little unclear with the ambiguity. I mean, yeah, okay. Actually, no, because I. Actually, I don't even need to do that. Is that always the case? I don't know if this is actually necessary, to be honest, but it makes my I feel like it just makes my understanding better. Okay. And now actually, oh, okay. And I've got to output this. What is that? Am I missing this in my code somewhere? Also, I reused stuff here. That's not great, but. Console that one maybe? I think I'm using Java stuff, but okay. Man. Oh. Which one is it? I think it's the length. Why is every language like always a little strange? I know I'm bad at this. Oh, that's fine. Okay, so it does what I want it to do. Okay, So now I can kind of just use a much more simpler maybe. But it could still be inside. So why did I delete all that stuff? Okay, well, it's fine. I'm gonna just go with this for now. So that part's right, but I have to also handle this case, for example, where I would totally just skip it. There's so many edge cases. Maybe I could do more. So basically, the case I'm thinking of how to handle is this one, for example, because we just don't really handle it right now. It's okay, actually. Oh my god, it's a mess. So now we just worry about stuff on the depth 0, which I guess could contain these things. So I guess I'm have to care about it. Yeah, maybe I'll do the commas first. Maybe I am a little ambitious and try to figure out what. Try to do everything in the same one. I think you probably could, but I'll just write it more naively. And we'll talk about complexity and stuff like that later. Shouldn't have that. Oh my god, it is such a mess. Oh my god. Okay. Yeah, I just need to figure out. I don't like how I wrote any of this. Okay, well. Yeah, I think we just do it one operating at a time. Okay. Yeah, okay, fine. Yeah, that's no. Yeah, maybe I just use that case. Oh my god. Maybe that's a special enough case. I don't need to. No, I need to do it this way. They may be on a different depth. So we took care of that case. Now what? Okay, well, you find the first operator that is in depth 0. Okay, fine. Where's it called? To make sure that's right. I actually don't remember it. Otherwise, if that's not the case, then we'll find the first depth 0 operator. There should be a set. Should it? Yeah. Yeah. I think one of the things that I find annoying about this farm is that it's probably a little tricky to test incrementally, so we might have to do a lot of debugging later. But what are we doing? Actually, I guess I could just do that. Why am I going to? Yeah, I should probably just add A to B or something like that. I'm just looking at the hope we don't want the memory issues. We create so many strings here. Transfer as a and I just probably true. Don't blame them. What's it going to cancel that? How did that happen? Off by ones probably. So I was doing this. Oh, okay, I'm happy with that. Also, this function is a little off. Making progress. Why does this take so long? I have not changed anything. Have I? That's wrong. Okay. So I just need to fix this. What the fuck? Also off by one, which that one I actually expected a little bit. Okay. I think I just don't have a base case. Which is actually here, because then you can't find anything on. I could actually probably start earlier. Oh, okay. Actually, didn't expect it to be sorted, so it might not actually be sorted in the end. It's just that I got a little lucky with that one. Well, also, we'll wait for it to be actually right first. But we made some progress, right? We got the first test correct. You know what they say, getting the first test correct is the key step on getting the second example test case correct. Yes. Okay. Okay. That's good. So I don't sound stuff. It's a shortcut here, but how is it? Yeah. Hold on. Yes. The expression is done if there are no operators and no commands. I guess, yeah, okay. Should also have no coast parent, but I think that's the same, so that's fine. Or mostly fine, maybe, but I keep on deleting these lines. Maybe I should just leave them in forever. Forever. Guess This is the big one. That's fair. I mean, at least this problem gives us. Actually, I thought about this one earlier, but I forgot. Okay. So the expression is not done. So there are two cases that I have to look out for then now. One is this case. I think actually it should fail even with just by itself. If not, then I should figure out why not. Okay. And then the other case, which is this, but with the A in the back. Oh, I maybe it failed on the first one, so it doesn't check the second case. I actually don't know how Leetcode structure this. Okay, so so this is I pause this here. Okay. So what I can do is just put in some additional Cartesian product things. Maybe. I mean, there's a way to do. I mean, that's not wrong, but just have to make sure I get it right. I hope this is sufficient. Actually, I'm not sure that it is. And I know that I'm missing the other one, but well. Oh yeah, because I tested the other case first. Okay. No, yeah. Also, man, I think I got lucky with, on the fact that you know, I guess there's a C# cat is character thing for it, but whatever. It's too late. Committed. I'm lucky that the braces and stuff like this is before the ASCII value, which is why that thing worked, but it's still a little bit lucky. That did not work. Well, oh, I think actually this is just wrong, that's why. Because their code is also a little funky on it. Mine is more right, but not true. Well, I'm glad that I found something that I'm actually also wrong about, but That's unfortunate though. Oh, because that's actually just wrong. Oh. Because the comma takes precedence on the tab. Yeah, because actually, oh man, I actually caught an edge case. Because even if you have something like a p, like what my code does is actually it takes this and then it Cartesian product before this. And I think it should do the comma first. Yeah, we definitely should do the comma first. So, okay, let me. Yeah, that is. But that's okay. We could probably actually just do the same thing. Once again, I didn't care for order of operation, and this is what happens. Okay. Also, mine stuff is not sorted, which actually I expected, and I don't know I didn't come out earlier. Sorted. Okay, so sort. Does that work? Or that to implement like an I comparator thing? I'm just lazy. I don't even know if sort actually returns an array value. Yep. Yeah. Well. Okay. Make sure I still have the first one correct. And also the second one, because apparently I replaced it with some other stuff. This looks okay. Fingers crossed. And if this takes too long, I don't know. Maybe I'll give it. Okay, cool. Thanks for staying with me if you're still here. John, I hope you're happy. I mean, it's I mean, this is a language construction. I think maybe I had to I had to take a notes. Yeah, I mean, memory usage. I mean, I don't think it's just the size of the input or output, right? So I don't know if I could do that much faster. But oh, I guess this is that part is the part you're talking about. And certainly this could be whatever. I don't care about that per se. Yeah. I think. Yeah. So this is a language parsing problem. I think it's an interviewee. It comes up. I'm not gonna be happy about it, but I could see it coming up. To be honest, this is a way. I wouldn't say a good problem necessarily, but it's not a bad problem. It's a reasonable problem. I think. I mean, maybe it's just not much to my strength. That's why I'm a little biased about it. But I think it's a reasonable problem to be asked on this, on some variation of this on an interview, in it because this is there's not that much what you might call it. There's not that much. There's not that much algorithmic things to consider, but it is a good problem for kind of demonstrating, your programming capability. Oh my God, this is 200 lines. Actually, shorter than I expected. It's just been a while since I've done these kind of problems. So I think I should be reasonably expected to code this up in good time. Maybe slightly easier version of this. There is some like, I wouldn't say necessarily intentional gotcha, but just like a little harder to kind of do certain things. They're definitely like slightly simpler, especially for kind of just making sure that we stay in this correct time like within the hour range, especially if it takes you like 5 to 10 minutes to just understand the problem. So I would probably simplify some of the language a little bit so that it could be coded in time, and but and it's a way, like an old school computer program problem. I think in general, I would not ask this as any real question. There's just so many things wrong, and also I think I would like the type of problems where you just, if you're a little off course, you could still get onto the right path. Where here, it's relatively straightforward, but there's a lot of like little off by ones and things that where you get trapped. And as an interviewer, like it's hard for me to be like, oh, maybe you just do this one little thing and then nudge into an idea, and because it's just all coding, and sometimes you just, I don't know, like miss something in a space somewhere, and like maybe I have a typo and this comma is a period because I just type it, and that could usually take me like 10-15 minutes to debug, right? So I don't know, but I think on the level of difficulty and stuff like this is okay. I mean, I think the next question that you may get asked is like, what's the complexity and space or whatever. The space for me is going to be output sensitive, meaning it just depends on a number of whatever, right? That said, you can imagine something like, I actually should have done this a little bit earlier so that to be more clear about, but you could imagine something like something like, it's not quite this, but something like this where dot dot dot, and for 50 it's just 50 divided by 3, which is 17, say. So 17, and then oh, well, no, that's not right. But you could do something like that actually. Like, I meant to write something like this, like basically 2 to the x, where each of these is 5 with 50 expressions, where the number of characters is 50, so that's 10. So you could have 2 to the 10, which is about 1024. So the only 1024 output I want to say is the upper bound. I should have done this analysis a little bit earlier. I was just I did notice it. I just didn't really think about it too much. So 1,000 up. It shouldn't be too bad. I don't know how you want to bound that. I guess technically it's 2 to the. I mean, it's technically 2 to the n over 5. Yeah. Which fun fact. Yeah. But so something like that. Yeah, so complexity. So that's the running time complexity also, because that's just the output, right? And you have to run at least that fast. So it's roughly 2 to the n, where n is 50, but not really, because it's actually 2 to the n over 5. And then and also the other way to, so that's the maximum of output, but also you're also bound, depending on how you want to do the math, each character, because you're only, each character will be looked at all of n times, because as you kind of partition them, you only read each character at most n times, right? So it'll be n squared. So you can bound it that way as well, though in this case, it's not as tight bound because of the parentheses and the operators. That makes it kind of that takes up more space than n squared strictly, something like that. But at least in this case, because it makes it like 2 to the 10. But yeah, so in short, I think I mean, I don't like these kind of problems kind of sometimes, but I also like reasonably would expect this to be, and this is a little bit on the harder side for an interview, but in general, like these kind of problems on an interview. So